Hello everyone, welcome to Beta Uganda. This is a continuation of the endocrine system, adrenal glands. The first gland we looked on earlier on was the adrenal gland. We are going to look at now the pancreas as an endocrine gland. The pancreas is both an endocrine gland and an exocrine gland, implying it can secrete either in directly its secretion in blood or in tubes, ducts. The pancreas is a flattened organ that measures about 12.5 to 15 centimeters in length. It is located posterior and slightly inferior to the stomach and consists of a head, a body, and a tail. Roughly 99% of the pancreatic exocrine cells are arranged in clusters called acin. Acin cells produce digestive enzymes which flow into the gastrointestinal tract through a network of ducts. Scattered among the exocrine, acin are 1 to 2 million tiny clusters of endocrine cells called pancreatic islets or islets of Langerhans. Abundant capillaries serve both the exocrine and endocrine portion of the pancreas. Each pancreatic islet contains 4 types of hormone-secreting cells. Alpha cells constitute about 15% of the pancreatic islet cells and secrete glucagon. Glucagon is responsible for rising up, converting stored fats to glucose, what's called gluconeogenesis. Beta cells consist of about 80% of pancreatic islets secrete insulin hormone. Insulin, which is responsible for decreasing the beta cells consists about 80% of the pancreatic islet cells that secrete insulin. Insulin, which is responsible for decrease of glucose levels in blood in case they rise above the normal glucose level of 90 milligrams per 100 cubic centimeters. So I will look at number 3. Delta cells consist about 5% of pancreatic islet cells and secrete somatostatin, which is identical to growth hormone inhibiting hormone secreted by hypothalamus. Number 4. The F cells constitute the remainder of pancreatic islet cells and secrete pancreatic polypeptide. Neurovascular supply of the pancreas. The superior and inferior pancreatic chordoidal arteries and the splenic and splenomesenteric artery supply blood to the pancreas. The veins in general correspond to the arteries. Venous blood reaches the hepatic portal vein by means of the splenic and splenomesenteric veins, students. Okay, so it's the venous blood that reaches the hepatic portal vein by means of the splenic and the splenomesenteric vein. The nerves to the pancreas are autonomic nerves derived from the celiac and splenomesenteric plexus. So the structure here shows the structure of the pancreas, location. We look at the gastroduodenal artery, dorsopancreatic artery, anterior pancreatoduodenal artery, duodenum of small intestine. Looking at the common hepatic artery, abnormal aorta, select trunk, splenic arteries, the spleen, elevated. Look at the tail of the pancreas, body of the pancreas, inferior pancreatic artery. Then looking at the superior mesenteric artery, and then the superior mesenteric artery, the inferior pancreatic duodenal artery, then at the head of the pancreas. So this is the structure. This yellowish structure diagram shows the pancreas and the major artery that supply the pancreas. Next, pancreatic islets surrounding the achin. So look at the blood capillaries these are the blood capillaries that supply the pancreatic islets, the cells. We have the inside cells, the alpha cells secreting glucagon. They are inside here, these ones, and the beta cells, they are a bit pinkish in color, secrete insulin. Delta cells secrete somatostatin, and then the acin cells, they also secrete pancreatic polypeptide, these ones here. Summary of the pancreatic isolate hormones. Hormone and source. we look at the principal action. Glucagon from the alpha cells of pancreatic islets of Langerhans. We have the alpha cells, these ones here, which are bluish here, I think. Raise blood glucose level by accelerating breakdown of glucose into glucose in the liver, a process called glycogenolysis, converting other nutrients into glucose in the liver, gluconeogenesis, and releasing glucose into blood. The insulin from beta cells of pancreatic islets, exocrine beta cells, lowers blood glucose level by accelerating transport of glucose into cells, converting glucose into glycogenesis process, and decreasing glucogenolysis. And gluconeogenesis also increases lipogenesis and stimulates protein synthesis. Somatostatin from delta cells of the pancreatic islets. These ones inhibit secretion of insulin and glucagon, and so absorption of nutrients from the gastrointestinal tract. Pancreatic polypeptide from F cells of the pancreatic islets. These ones inhibit somatostatin secretion, gallbladder contraction, and secretion of pancreatic digestive enzymes. Thank you very much for watching. Please feel free to subscribe. We love you so much, and stay tuned. Turn on the notification bell for more upcoming lectures about the endocrine system. I'm going to continue with the ovaries in the next chapter, so don't miss out the lecture. Thank you very much. Stay